Well, this presentation is very similar to Alberto Plana's one, but it's part of my master thesis. So it's a more unique way to measure the participation in an open source project. The motivation to do a presentation or a thesis like that was that there was no previous work concerning academic world related to openSUSE project. There was a motivate to explain how the software is being evolutionized and how the users interact with this truth. And of course, there was no previous information regarding to the contributors and the activity of the members of openSUSE. So, I used some tools provided by the local research group of the master studies that I had. These are open source tools. The first tool is CVS Analy that downloads and stores in a local database a local repository with commit IDs, with date, with all the relevant data. The second tool is the mailing list stats, which downloads a specific mailing list that we identify, stores all the data in a local database like CVS Analy. The third tool is Bicho, which analyzes and stores in a local database an issue tracker. This can be a bug tracker, or for example, an issue tracker from GitHub. The SLOCCount is an open source tool as well, which analyzes the cost of an open source project. So the only thing that you have to do is to run the tool, and then you get some information regarding to the cost. The last two tools, visgrimoire R and visgrimoire.js. The aim of these tools is to create a dashboard that can provide all the data related to the first three tools, to CVS Analy, mailing list stats, and Bicho. Visgrimoire R generates all the metrics, and visgrimoire.js visualize all the generated from visgrimoire R. So, the steps are, first we mine the source code repository that we want to mine. Could be from openSUSE or could be from another open source project. The second step is to mine the mailing list from the project. Then we mine the issue tracker. We analyze the source code repository for regarding to cost with SLOCCount. Actually, Git stats is a tool that finally I didn't use for analysis, but it's very relevant to CVS Analy with focus on only Git repositories. Then we run the visgrimoire R in order to extract all the metrics. We use the R language for that. And the visgrimoire R provides us JSON files as an output format. Finally, we visualize these JSON files with visgrimoire.js, and we have all the plots, the diagrams, and all the information visualized and plotted. So, following these steps is not enough. We have to define the condition analysis, the analysis of the project. So the conditions are: we focus on the analysis of the software development, because there are repositories, for example, like artwork or like other repositories that can analyze, but was out of our interest. We assume that the discussion and the software evolution takes part in the mailing list of each project. Likewise, we assume that the bug fixing and the bug reporting is being implemented via the issue trackers. The source code repositories, the mailing list, and the issue trackers have to be analyzed from the tools mentioned before without any error. Actually, I had an error while analyzing the kernel project. So, the main condition is that the repository, the issue tracker, and the mailing list has to be associated. So, you cannot analyze the factory repository and analyze the open build service mailing list and analyze the issue tracker from time load, for example. So we need all the data to be the same, related to the same project. Would be the Open Build Service repository, the Open Build Service mailing list, and the Open Build Service issue tracker. Another condition, which is the last one, is that we selected projects from openSUSE that have a high activity, which means high number of commits. So as an example, I analyzed the Zypper project. So in this diagram, at this axis, we see the number of commits, and this is the timeline. This is a bubble diagram. So the bubble represents the amount of people that have this amount of commits for this period of time. For example, in October 2011, we see an amount of people with almost 25 commits. This can be more interactive while running it in the dashboard, but as I had to make a presentation, not a workshop, I just took a snapshot from the diagram. As a metrics, we can define, for example, the top authors from the last year, the authors per repository, the number of files, the number of branches, the lines that developers and committers removed, added, the commits per repository. In our case, it's one repository, so just the commits. Apart from the source code repository, I analyzed the mailing list. So, likewise, we see the bubble, which represents the amount of people that sent these messages, and the amount of messages sent. And at this point, this is the timeline which begins from March 2007 and lasts until May 2013, because I mined and analyzed the data until May 2013. So, as example of metrics, we have the people, the top senders, the senders per company. So, in a mailing list like Zypper can participate people from SUSE and people from the project. So we can identify who are from the project and who are from the company. Likewise, we can find how many people sent messages per repository, and the message sent, how many people sent messages. So here we have the issue tracker. We define as tickets every issue submitted to the repository. Actually, GitHub provides an issue tracker, so we analyze the issue tracker provided by GitHub. We started from November to 2011, and we stop at May 2013. These are the number of the tickets. So we see that the highest number of tickets opened are 7, and it's between September 2012 and February 2013. Likewise, we have tickets opened, tickets closed, openers, ticket closers, and ticket closures per repository, because we can make this kind of analysis for more than one repository. Apart from the tools that we run, we made a cost estimation of the project. In this case, it's Zypper. So by running the SLOCCount, you get these results, which is the source the sloc, which the total amount of the total lines of code, the effort which we calculated based on the COCOMO model, so which means person per month, the schedule, so we make a schedule estimation. Then we divide the effort with the schedule, and then we made the cost estimation for the development, which is in dollars, and we assume that the average salary is $56,286 per year, and the overhead is 2,40. These are the default configurations. So if somebody wants to change the average salary or the effort or whatever has to interact with the source code of the SLOCCount tool. Okay, but we have, apart from the analysis, we had some problems. At the beginning, the goal was to analyze 3 projects: the kernel project, the Zypper project, and Open Build Service. Due to a bug to the tool, CVS Analy, we didn't manage to analyze the kernel. So we focused only on Zypper and Open Build Service. If you have a look at the GitHub page of openSUSE, you can find more than 100 projects hosted in the official web page, in the official repository. So it was difficult to find a project that fulfills all the conditions to run without error, to be associated with a corresponding list, and to be associated with the corresponding issue trackers. We found many projects that fulfill these conditions, but some of them didn't fulfill, but we need a high activity, so what means high number of commits of the issue tracker or from the source code repository. Another problem that we faced is related with the software, because visgrimoire R and visgrimoire.js have many dependencies in R. So many dependencies are not packaged. So we had to face all these problems and make the tools to be able to run. So the main problem was that these tools, visgrimoire R and visgrimoire.js, will document it and package only for Debian-based distributions. Even if in Fedora, for example, the R packages, the necessary R packages, were not available in RPM format. So the solution is to study the how-tos and the documentation in order to install properly the tools. When facing a problem, contact to the corresponding person for solutions or searching to the web. Compile from scratch all the dependencies and make them run. Report any issue or bug faced due to runtime errors or while using the tools. Contact the developers in IRC, in a mail, or personal. And document the whole process so anybody in the future can repeat this kind of analysis. So as a future work, I could state that the first goal is to solve the bug related to the tool and analyze the kernel repository of openSUSE. As Alberto showed before, it's a good idea to interact with, to show the social media interaction, of the developers and contributors, to apply the same methodology explained before in other free and open source distributions, to compare the package manager, now it's Zypper, with YAM because it's RPM based, to compare other Debian-based package managers, for example, apt-get with other Debian package managers, and to make research on the developer's activity, if they solve the bugs, the number of commits, their participation in repositories, who is the core team of developers in each project. Any questions?
What's the reason behind not analyzing any repositories that don't have an issue tracker or a mailing list attached to them? Your results are unpredictable, you can't get enough information. What's the point behind that?
The main reason is to see if the contributors solve the bugs, or if they participate in the issue tracker, or if they communicate via the mailing list.
Okay.
Can there be metrics on marketing? I mean, can you find some variables in order to measure marketing work?
If they have a repository, yeah.
No. That's what I meant. Excuse me. Is there a way to do something like that
Mhm.
as a metric in something that actually has not a repository? I mean, if I remember correct, you tried something like that on Connect, right? A few years ago.
Yeah,
What happened to that?
nothing, finally. But for the marketing, you can use the mailing list as a measurement, as a metric. So you see people, if they post in the marketing list, currently there's no tool to analyze the participation in the forums or in the IRC. For example, to analyze the log of a meeting, of a marketing meeting, to see if the people are participating.
Is there something like make the bot measure and send that measurements and then something like...
Yes, but I need the log files of the IRC, for example.
Yep. I'm just
Yeah.
asking. Thank you.
This can be done, I mean.
Another question? Thank you.
Thanks a lot.